Okay, so section 1.6 is going to be mostly graphing. Graphing and looking at parent functions and transformations. So the two kind of graphs you're going to have to make are your greatest integer, which are also called your step functions, and a piecewise function. So the greatest integer functions, these look like this. They have a double bracket around the variable. Okay, and the reason why they're called step functions is when you graph it, it actually looks like stair steps. So it would look like this. It actually looks like you're making steps. So that's why it's called a step function. Your piecewise function is any time you have multiple parts going on. So let's say I have x if x is less than 0, negative x if x is greater than or equal to 0. This would be a piecewise function when you have more than one part going on. Okay? So a couple things I want to point out. The step function, the left-hand side is always your closed circle. The right-hand side is your open circle. The other thing is on your pieces, pay attention. No equal to sign has an open circle, equal to sign has a closed circle. Okay, I'm going to go through these examples kind of quickly, so make sure you pause it if you need to pause, write things down. Okay. So first thing we're going to do is we're going to do step functions. So this is my step function I'm going to graph. I just want you to do t-chart on all of these that are step functions from -2 to 2. All this means is that means we can't have any decimals in our answer. So if we put this number in, we need to make sure we round it to the greatest integer. You don't have to worry about that if you plug in integer numbers. So -2 minus 2 is -4. -1 minus 2 is -3. 0 minus 2 is -2. 1 minus 2 is -1, and 2 minus 2 is 0. So when you go to graph this, you're going to plot your points. So -2, -4, -1, -3, 0, -2, 1, -1, and 2, 0. You'll notice I made all of those points solid. Then what you're going to do is you're going to make steps. So this is going to go straight across till I get to the next point where it steps up, and I'm going to make an open circle. This one's going to go straight across where I get to where it should be, make an open circle. So every time you get to where it's going to step up, you're going to make an open circle. Okay, I want you to do at least these 5 points. If you want to put more points on it, then that's totally up to you. Okay, so there's your first example. Okay, we're going to do the same thing on this one. And all the double brackets mean you don't do anything special, just means that's going to be a greatest integer or a step function. Okay, so I'm going to make my t-chart. Use -2 through 2. So -2 plus 1 is -1. -1 plus 1 is 0. 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1 is 3. And I'm going to plot my points. -2, -1, -1, 0. And I didn't do that point right. Sorry. Start over. -2, -1, -1, 0, 0, 1, 1, 2, and 2, 3. Same thing. We're going to make the steps. They get over there. Open circle. Every time it's getting ready to go to that next point is when you stop and make it an open circle. If you want to make more than 5 points, totally up to you if you want to, but I want these 5 points in your t-chart. Okay, so those are your step functions. Okay, now I'm going to do a couple of piecewise examples. On these you can make T-charts if you want to. I honestly think that's the easiest, but you can also put them in slope-intercept form and just graph from there. So you're going to have two separate parts. So this is my first part that we're going to focus on. The 2x plus 3, and it says if x is less than 0. I'm still going to plug in 0 because that's a barrier point, okay? But I know that this circle is going to be open because there's no equal to sign. Okay, and then I want numbers that are less than. So just pick a couple numbers that would work, and I'm going to plug them into this equation. So 2 times 0 is 0, plus 3 is 3. 2 times negative 1 is negative 2, plus 3 is 1. 2 times negative 2 is negative 4, plus 3 is negative 1. Okay, this is your only point. When I go to plot that, 0, 3, that's going to be your only open point. The rest of these make a line. So this is going to be your line that goes on forever. Okay, the other part is for numbers that are greater than or equal to 0. So I'm going to use 0 again because that's our transition or our border point, whatever you want to call it. But since there's an equal to sign, I know it's going to be closed. And I want a couple numbers that are greater than or equal to that fit this scenario. So when I plug it in, 3 minus 0 is 3. 3 minus 1 is 2. 3 minus 2 is 1. So this time when I plot this first point, it's going to be closed. Okay, they just happen to be in the same spot. That's not always going to happen, but this one happens to be. Then I have 1, 2, 2, 1. So this is the other part of my graph. So there are two pieces. These two pieces are fitting on one coordinate plane together. Okay, I'm going to do one more piecewise. Okay, so the first one is x squared plus 5, if x is less or equal to 1. And the other one, negative x squared plus 4x plus 3, if x is greater than 1. Okay, so I'm going to do the first one in blue. And this one says less or equal to 1. So I'd have 1, and this is going to be closed because I have the equal to sign. And then I want a couple numbers less than.
Hey, Reactor, if you're in the building, you need to come to the office right now. Thank you.
Okay, so I have 1 squared, which is 1, plus 5 is 6. 0 squared, 0, plus 5 is 5. Negative 1 squared is 1, plus 5 is 6. Okay, these are quadratics, so there's a chance you're going to have a curve in them. So I have 1, 6, 0, 5, negative 1, 6. Okay, and the numbers are going less than, so when I make this, my graph actually is going to look like that. Okay, the second one I'm going to make in purple. Same border at 1, but this time it's going to be open. Make sure you follow your order of operations. So when I square this first, then I multiply by negative 1. So 1 squared is 1 times negative 1 is negative 1. Negative 1 plus 4 is 3. 3 plus 3 is 6. 2 squared is 4 times negative 1 is negative 4. Plus 8 would be 4, plus 3 would be 7. This would be negative 9 plus 12, which is 3 plus 3, which is 6. So this is 1, 6, which is open, but there's already a point there, it's okay. 2, 7, 3, 6. So this one's actually going like that. Okay, the graphs could look weird because you're putting pieces together, but it's okay. Just graph each part separately, but you're putting them on the same coordinate plane. Okay, that'll take care of your graphing. The next part are your parent functions. These should all be familiar from Algebra 2. So your constant is when you just have it equal to a number. And when you're looking at a graph, if it's equal to a number, that means you're going to have a horizontal line. Okay, parent function for linear is equal to x. When you're looking at a regular graph, this is when you're making the straight, but it's a diagonal line. Okay, parent function for absolute value. So you have the absolute value bars. This graph, these are the ones that make the V's. So it'll look like that. Square root. Remember, you can't take the square root of a negative, so when you're looking at these graphs, they start at 0 and they go to the positives, and they kind of make like a little arc. Quadratics are your x squareds. You should know what those look like. They're your parabolas. Your cubic are your x to the third. And those look like this. It's where they start one way and they change directions. Okay, reciprocal we have not done much with this year. We did it in Algebra 2. This is when you graph and you have two parts because you have asymptotes. And this is what a normal one looks like. But you can have graphs beside each other or the diagonals, but this is what the parent function, so the most basic. And then your integer function, your greatest integer function, which is what I talked about today. And I talked about in Algebra 2 as well. This is your step function, so the ones that make the steps. Okay, you're going to have to be able to recognize parent functions and know how to use parent functions. Okay, my last slide are the transformations. These are the same transformations that we will use for every single kind of parent function, from constant to quadratic to square root to cubic. When I'm saying outside, that means outside of the parentheses or outside of the square root. Inside is inside parentheses or inside the square root or inside your brackets if you're doing greatest integer. Negative in front of the whole function and negative in front of the variable only, those are your reflections. Okay, this is going to be stuff that you need to know to do page 71. Okay, this will get you through tomorrow. I'll have tomorrow in class to work on this. So I guess today, because most of you are going to watch it probably on Thursday. I will be back on Friday to go to the next section, but if you have questions, make sure you ask.